Hi Calculus, welcome back. We are going to take a little bit of a break from area volume here and do some chain rule review. So I've got the checklist on the screen, you know what to do from here. And force another pause on the screen. Can you go ahead and copy the 4 functions I have on the left? All right, we're back. So for each of these, we want to find the derivative f prime of x. And each of these involves a chain rule. However, for each of the given f of x's, the inner function is linear, right? So in this case, my slope is -3. In this case, the slope or the derivative of the inner is 1/2. Here it's 3, and here it's 1/3, okay? All right, so let's do the first one together, and then I'm going to have you do the rest on your own. So you can see that it's chain rule because the outer is e to the x, whose derivative is just itself, right? So I've got, make sure you're labeling what you're finding, f prime of x equals, so the derivative of the outer is itself, and I'm holding the inner. And then I want to multiply by the derivative of the inner, so just multiply by -3, right? So here's the derivative of the outer holding the inner, multiplying by the derivative of the inner. All right, and force pause on the screen. Can you try the other 3 on your own? Hit continue when you're ready to check your answers. All right, I've got the answers on the screen. Don't forget for this last one that we'll need to rewrite, always rewrite square root as that inside stuff to the 1/2 power. So I've got the derivative here. If we clean this up, which would be preferable, let's bring the coefficients to the front. 1/2 times 1/3 is 1/6. So probably seeing it written like this would be more common. Force pause on the screen. Can you go ahead and copy the 2 functions I have? All right, we're back. We've seen these 2 functions before, but this time let's find an antiderivative, capital F of x, for each one. So before we took the derivative of the outer holding the inner, then we multiplied by the derivative of the inner. We've done this before. This time we will take the antiderivative of the outer, which is itself, and then divide by the derivative of the inner. So instead of multiplying by -3, we're going to divide by -3 or multiply by -1/3. Okay, and this would be one antiderivative. If I wanted to find all of them, we would want a plus c there, right? Force a pause on the screen. Can you try the next one? Hit continue when you're ready to check your answer. All right, so again, I am calling the antiderivative capital F. So let's check our answers here. If we did this correctly, then if we take the derivative, we should get back to little f, right? So if I take capital F prime, I'm going to have that -1/3 come with me. And then the derivative of this, we said earlier, was -3e to the -3x. Derivative of c is 0. And so, yes, this does indeed get me back to where I started, right? I know that when I derive, I'm going to get this factor of the derivative from the inside, so that's why I need to multiply by its reciprocal or divide by that same factor to get rid of it, okay? If I try to take the derivative of capital F here, I'm going to have that 2 come with me. The derivative of sine is cosine, holding the inner. And then multiplying by the derivative of this would give me that 1/2, and so those go away, and I do get back to where I started. All right, good. Force a pause on your screen. Go ahead and write these down, and then we'll do them together. Okay, so if I took away the 2 and the 3 on this first f of x here, I would have 1/x, right? That would be the kind of the parent function, right? So if I want an antiderivative, then the antiderivative of the outer, what's the antiderivative of 1/x? It'll be ln of, and I'm going to hold the inner, make sure we're doing absolute values because we can't take log of a negative. And now I want to divide by the derivative of the inner. So the derivative of the inner is 2, so I'm going to divide by 2 or multiply by 1/2, okay? And we can check this by taking the derivative, right? Let's try that real quick. So if I take the derivative of capital F, the 1/2 is going to come with me. Derivative of ln of 2x plus 3 will be 1/2x plus 3 times 2, which is going to cancel with the 1/2, and we do get back to where we started. Okay, for this next one, what do we need to do first? We need to rewrite, right? like so, okay? Now that is not the antiderivative, that is just a rewrite. So now we're going to antiderive. Is the inside linear? It is. So this way I can go kind of an anti-chain rule, right? Antiderive the outer, divide by the derivative of the inner. All right, so let's do that. Antiderive the outer, holding the inner. So let's hold the inner. I need to bump the power up by 1, so that'll be 3/2, and then divide by 3/2 or multiply by 2/3, right? Then I need, that's the first part, that's antiderivative of the outer. Now I need to divide by the derivative of the inner. So I need to divide by -3, which will be the same as multiplying by -1/3, okay? So just cleaning this up a bit, bringing the 2/3 and the -1/3, I'm going to get -2/9 in front, and then I still have this -3x minus 1 all to the 3/2 power. Let's maybe let that one sink in just a bit more. Why don't you try one of those on your own? So I'm giving you little f. Can you find me capital F of x? All right, I've got the answer on the screen. If this is not what you got, go ahead and pause and correct any work you need to. All right, will you write this sentence in your notes? And I know we've done this, but this is just so important. This only works when the inside function is what? Is linear, right? Like if I give you f of x equals cosine of x squared, and I try to apply this anti-chain rule. So I antiderive the outer, hold the inner, and then I divide by the derivative of the inner. Well, if this were to work, then the derivative of this should get me back to this, which it's definitely not, right? The derivative of this would require a quotient rule. You'd end up having a 4x squared in the denominator, which is certainly not in the original. So this doesn't work, right? This does not work unless the inside function is linear. So in other words, the derivative is just a nice number, just a nice coefficient, and those factors I can deal with. But as soon as I start introducing variables from the derivative, we have some big problems. And in those kinds of instances, that's when you hope maybe we can do some kind of U substitution. But right now, again, we're just focusing on when the inside function's linear. All right, so will you write this function, for example, for y equals f of the quantity 2x plus 11. So if I'm going to derive this, we're going to derive the outer, f prime, hold the inner, and then we're going to multiply by the derivative of the inner. Right? Now, if I want to antiderive, let's call it capital Y, then we're going to antiderive the outer, so let's call that capital F, hold the inner, and then divide by the derivative of the inner. So divide by 2 or multiply by 1/2. All right, remember synthetic division, hopefully from both pre-calc and algebra 2. I'm going to force pause on the screen. Can you go ahead and write that rational expression in your notes? All right, so this is a rational expression, rational fractional. So if I wanted to try to antiderive something like this, I have a problem, right? Because I've got this quotient. I don't have an anti-quotient rule. But do notice that your denominator is linear. So let's try rewriting this by using synthetic division. So remember that you put your 0 in the corner, so -2. Grab your coefficients in descending order, making sure you have no missing terms, right? Then you're going to bring down the 1, bring down the first term. Then you're just going to multiply and add until you've filled in your matrix. So multiply diagonally, -2, add straight down, that'll be +1, multiply, -2, add straight down, that'll be -3, okay? So I'm getting x plus 1 with a remainder of -3. In other words, -3 over my divisor of x plus 2, right? So this whole thing can be rewritten like so, x plus 1 minus 3 over x plus 2. Why do I care about that? Well, let's say I want to actually integrate that. Well, let's say I want to find the antiderivative. And force pause on your screen. Can you write example 5, please? Okay, so we know that from the previous screen that the integrand is the same as x plus 1 minus 3 over x plus 2, right? That's what we got over here, all right? Now I'm just asking to integrate, right? These two symbols together mean antiderive, integrate. Okay, so we're going to go term by term. So that first term I have 1/2 x squared. The second term I have a plus x. And now here, think of that -3 as just a coefficient, comes along for the ride. And then I've got 1 over a linear factor, right? So if I take off that 2, notice that the parent function is 1 over x. So I've got ln of the absolute value of x plus 2, because when I derive ln of x plus 2, I'm going to get back to 1 over x plus 2. That -3, again, just comes along for the ride. Okay. All right, let's try example 6. This time we have a definite integral. So same process, I'm still going to antiderive, but then I need to plug in 3 and 1. Go ahead and do synthetic division for me. So copy the example, do synthetic division for me, and then let's pick up from there. Okay, here is what I got. So we can rewrite the integrand. I still have integral from 1 to 3, but the integrand can become x plus 2, which is great because those I can antiderive easily, right? Then minus 5 over x plus 2 dx. Okay, so once again, these two symbols together mean antiderive this stuff. In this case, then we'll also plug in 3 and 1. So an antiderivative, again, is going to be 1/2 x squared plus 2x. Now that last term, the -5 comes along for the ride. It's a coefficient. And the antiderivative of 1 over x plus 2 is ln of absolute value of x plus 2. I do technically need to divide by the derivative of the inner. I should have mentioned that, but the derivative of the inner is just 1, so that's why we don't have anything extra there, okay? And then I want to evaluate this at x equals 3 and x equals 1. Okay, I'm going to go ahead and let you plug all that in. Hit continue when you're ready to clean it up. All right, so here's what I got when I plugged in. Now let's go ahead and simplify this. So I've got 9/2 minus 1/2, so that's 8/2, which is 4, plus 6 is 10, minus 2 is 8. Now let's write our logs. Let's always write your positive log first. So this is a negative times a negative, so that's actually positive 5 ln of 3. I dropped my absolute values because 3 is positive, and then minus 5 ln of 5. I have parentheses around here or not, either way. Okay, so this very last part, if you remember from pre-calc and algebra 2, when you have logs separated by a subtraction sign, you can bring them into one log using division, okay? And we'll review this rule more, but I just want to kind of remind you of that. This is the simplest form we can write this in. All right, that is all I have for today. Be sure to write a summarizing sentence, and I will see you all next time.